Hi King Lions. Today we're going to be talking about solving multiplication problems and how the strategies that we've learned in class and the strategies that you should continue practicing at home. Memorizing your facts is the best thing you can do. We're going to talk about how to solve facts you don't know. So obviously if you've memorized your facts, you're a step ahead and you're ready to go. But we're going to talk about how to use those facts that you have memorized to solve ones that you haven't memorized. The first thing we're going to do is we're going to talk about doubling. So if we know the fact 2 times 4 equals 8, then I know I can double a factor and solve 4 times 4 by doubling the product. So I should be able to look at the problem of 4 times 4 and say, I don't know 4 times 4, but I do know 2 times 4. So how can that help me? Same thing if I have the fact of 6 times 4, and I don't know 6 times 4, but I do know 6 times 2. If I double my factor, I double my product, so that would be 24. A lot of the kids will use this as they're building their derived facts, and then as they memorize their derived facts. So the foundational facts are the ones they've memorized. They've memorized zeros, ones, twos, fives, and tens. And then we call the other facts derived. So I'm using those foundational facts and I'm building on that. So I'm thinking bigger. It's more than just multiplying their facts. So when they learned to add and subtract, they did +1, -1, and they learned that. We called them near doubles in 2nd grade. So in 3rd grade, when we do multiplication and division, we talk about adding and subtracting sets. So if I have the problem 8 times 6, I can think of this 6 as 5 plus 1. And I don't know 8 times 6, but I do know 8 times 5. And I do know 8 times 1. So all I'm doing is breaking this down into 5 plus 1 and kind of distributing my 8 through it. This is the strategy that we're going to use when we get to double-digit multiplication. So 8 times 5 is 40, 8 times 1 is 8, 40 plus 8 is 48. So all we did was decompose this into 5 plus 1, and then we used a fact we know 8 times 5, what's one more set of 8? They do this when we get to the 9s. So if we had 9 times 7 equals something, I can use a fact that I know. I know 10 times 7 equals 70. This is one less set of 7 is 63. So what does that look like? If I have 1, 2, 3, 4, 5, 10 sets of 7, I have 70. But if I take one of those sets away, I have 9 sets of 70. So 70 minus 7. Sometimes when they're first learning this, they will take away 1 and they will say 10 times 7 is 70, 9 times 7 is 69. That's a stepping stone, and that's okay. We go back to drawing the picture and saying we're not taking away 1, we're taking away 1 set. So this is also a strategy that they have learned and should be practicing because it helps kind of broaden their thinking about multiplication beyond just memorizing facts. All right, so let's talk about, let's see, we've done the number line. So if we have a fact 4 times 7, and I want to put it on the number line. Number lines in addition and subtractions always start and end on 0, unlike addition and subtraction, always the 0. So if I'm multiplying, I'm saying this is 4 plus 4 plus 4 plus 4 plus 4, 1, 2, 3, 4, 5, 6, 7. Now here's a word of caution. This number line is going to give me the right answer, but this number line, I actually drew it backwards because we've been out of school too long. This is 4 jumps of 7. So we have to distinguish between representing a fact and solving a fact. I'm using this number line to solve. This does not represent it. The correct number line would be 7 plus 7 plus 7 plus 7. So it's just an important distinction. The kids will use either to solve, and that's okay. More so in division than multiplication. It's okay. This one though, when we look at it, we can really see the half. I know that this is 7/14, and then I'm doubling it. So sometimes drawing the number line helps them to visualize that this is half, and then I just double. So we get really good at doubling. Can you tell if you don't do it often, you get out of practice. All right, let's talk about multiplying double digits. In 3rd grade, the standard reads that they will multiply double digit by single digits up to 99 times 5. So they don't have to be able to multiply past 5, but my feeling is if they can go to 5, they can go to 9. So I try to keep it within the standard. So we would go 72. I tend to do like 3s and 4s because they already know their 5s and they already know their 2s. So I try to force them to think just a little bit. It's important to know that in 3rd grade, they do not do the standard algorithm where you line it up like this. We do not do that in 3rd grade. The mathematical reasoning is not there yet. So this would not be an appropriate strategy to be doing at home. Once they understand the reasoning behind it, in 4th grade, they will learn that algorithm. But in 3rd grade, we don't do that. It is important that they understand what they're doing, and that is more complicated than the one in addition and subtraction. So I'm not going to teach that. I'm not going to use that in videos. I'm not going to use that in class because it's not a strategy we use. We do a couple different things. This is where we break the rules on the number line because this is technically 72 jumps of 4, but I'm solving it, not representing it. So I can do 4 jumps of 72 on my number line, because I'm using that as a strategy to solve, not represent it. So if I have 72, I'm going to double that to 144, and then I know, oh look, I can double it again. I'm at 288. I'm not even going to put that number in there because I don't want to do that. I can tell by this is half, here's another half, I just have to double it. We talk a lot in 3rd grade about efficient and inefficient strategies. Inefficient strategy would be drawing 72 circles and putting 4 in each and then counting them. That would take way too long, and we should really be well beyond that by now. That's a strategy that we use when we're doing single digit. Another strategy that they learn is that this is the same as 70 plus 2 times 4. So I'm taking this 72 and I'm breaking it up, and then I'm going to distribute the 4 through the problem. So 7 times 4, 7 1 times 4 ones is 28. So 7 times 4 would be 28 tens. 7 10 times 4. Plus 2 times 4 is a fact I know. I add my partial products together and I have 288. So this is one way that a lot of the children have chosen to represent this problem. We can also do that same strategy on what we call the box method or the unmarked array, where they draw a rectangle. Theoretically, we're drawing 4 rows, like this is why we do the rectangle, and 72, but that would not be efficient. We would lose our efficiency. So we do what's called an unmarked array, where we just draw the box. And we're going to take this 72, and we can divide it anyway, and you'll be impressed with the ways that your child has, if they know this strategy, they divide it all different ways. But here we are again with 70 times 4 is 280, 4 times 2 is 8. There are my partial products. I add them together and I have 288. So you will see, some of them do crazy things. Some of them will like to split it this way. They'll do 72 and 2 and 2. They'll split up the 4. They could, if they wanted to, do both They could do 72, 2 and 2. It just depends on how many parts they want to put together. So I have 140 and 140, and I have 4 and 4, and now I have to put all those parts together. So I like this strategy because they can do bigger and bigger and bigger numbers. It doesn't matter how big their numbers get. They can multiply to the hundreds. If this works for them, this is a great strategy. Some of the students are at the point still, or as of March 13th, where they had to draw pictures. 3, 4, 5, 6, 7, 1, 2, 3, 4. And then they counted. So some of them were still there, and that's okay if that's where they are. We're working towards saying, I can do this simpler. I always tell them, work smarter, not harder. So that's how we would do double digit by single digit multiplication. And again, we would use those strategies that we learned. Like if we had 72 times 5, and I had just solved, and 72 times 4 is 288. Well, I know this is just one more set of 72. So I just need to add 72 to my product. So we want the students to be able to move freely between problems and make connections and say, oh, I just solved that one, I can solve this one. That's our ultimate goal. And then we know they're ready for that algorithm. They're ready for more advanced multiplication and division. So we're also, my next video is going to be division strategies and what we've done in class and what you should be doing at home. So come back for division.